between two stations, acceleration from rest, and finally comes to rest here. Track I can't show. Only the train is what, and I'll show it. Okay, there's a train. This is a track. It will accelerate from rest to rest here. So first what happen, it will accelerate from rest. The train will have accelerated motion. Like similarly, previous problem what we discussed, no, that was a car. No. It will accelerate, then uniform velocity, and then finally it will come to rest here. The ratio of times, the times ratios here is given. So therefore this time we'll call T. This has 8T. This is T. Maximum speed attained is some other color will choose. And it was moving from rest to rest. Okay, no, definitely I can say that the acceleration must be same. The acceleration, the amount of acceleration retardation must be same. Any reason for that? Because look at that. The time interval for acceleration and the time interval for retardation is same. So the acceleration and retardation have to be same, or else you write equations of motion. What is that? Vm is equal to 0 plus alpha t. This is then similarly 0 equal to Vm minus beta t. With this alpha equal to beta, I'll get it, and that should be equal to A. It undergo retardation, no? Because it is going to describe here uniform velocity motion. So what distance it will cover during this period, the same distance is going to cover during this one. So with this, looking at this, I can also write x1 equal to x3. Average speed over the whole journey is asking. So now we know time interval. We know the distances here. So what is the basic definition of average speed? Average speed should be equal to x1 plus x2 plus x3 by t plus 8t plus t. What is x1? X1 should be equal to a t square by 2. What is x2? Vm into t. Vm into 8t. This should be equal to what is x3? X3 is also equal to Vm t minus a t square by 2. But we know Vm is equal to I think I'll write these symbols. Huh? Some of you are getting confusion. And we know alpha equal to beta, no? Can we write also Vm equal to this alpha t? And alpha equal to beta. So further, this will be V average is equal to alpha is equal to beta equal to A, I'm writing. So this will be 8t square by 2, 8 VMT. Vm is what? 80 into t, this is 8t square by 2. Alpha equal to beta is what we wrote. So this should be equal to 8t square by 2. Vm is what? 80. 80 square, this will be 80 square. So this should be 10t. For everything, we can replace in terms of Vm also. Okay, this 80 square, 80 square 9, 80 square by 10t. So 9 by 10, 80. What is 80? Vm is equal to 80 is what? In place of 80, I'm writing Vm. So V average equal to 9 by 10. So what is this? This is 60 kilometer per hour. So 9 6 54. 54 kilometer per hour will be our answer. Of all, this data is very important. It will accelerate from rest. This is for retarding motion. The time of acceleration and time of retardation are equal. That was given here, the ratio. Therefore, this alpha and beta must be same retardation. The acceleration must be equal to retardation. This is one more important data. I'll underline it. Here is what I substituted 80 as Vm. Please do notice. How suddenly that Vm has come, because Vm equal to 80 is what we have derived from here. This is may not be important. Just I wrote it. Even x1 equal to x3. This I'm showing it separately here. This you may find difficult. I'll eliminate it. May not be needed here now. Okay, again, what about the graph? Because every time I'm insisting on the graph. Okay, again, the same methodology for the graph. I'll try to accommodate here only. First, the train will accelerate, uniform velocity, then retardation. Then we know how to plot such graphs. Accelerated motion, uniform velocity, then this one, then retardation. Every problem. Sir, can you plot the acceleration versus time graph also? You are showing only these things. Okay, let's try that also. First, acceleration. So acceleration, how do we represent? Then uniform velocity motion. Acceleration will be 0. Then retardation. Okay. Oh, everything you try to develop now only. This is acceleration. Accelerated motion, retarding motion. Acceleration 0 means uniform velocity motion. I show the complete description of the problem. A student has to fight. There's no other way. A student has to fight with the concepts. Okay, I'll continue the next class. We'll wind up this one. The coming classes, we'll discuss few more numericals on this one. Okay, I'll finish off this. I think it's got some more left over. We'll continue the next class, this one. I think we stopped it here, no? Yeah. Okay, complete description. The last problem. This is what the discussion what we made. Okay, the idea of that train accelerating, uniform velocity, then retardation. Retardation means beta should be opposite. The train will come to rest means here you can apply equations of motion v equal to u plus at. So all our numericals, what all we are discussing revolves around how you apply equations of motion, nothing big. Just stick onto that equations of motion, you can manage. Okay, we'll end up the class. Okay, no. Kids, today what happened? You had some discussion about the first.